Hello everyone, welcome back to Turtles Cove Media. I'm glad you're here, whether you're here to watch, learn, or you just need to decompress for a little bit. I'm glad you stopped by. So we're going to get right into it today. So we've been working on our very own version of Tetris. And so the last few episodes, we've got our window going, we got our grid, we can spawn in our Tetrimino pieces, and we can even make them fall and we have some user control over that. And so first things first, we're going to make sure our code is working like it's supposed to, like last time. So what we should be, we need to see the window, which we do, the grid, which we do, the Tetrimino piece, which is pulled at random, which we do, and we can control it, give a left or a right, and down. We cannot move up because we don't want to. Now we will be, next lesson, we will be using that up arrow for a purpose, but otherwise, there we go. That's where we're at. And so what we're going to be doing today is we're going to be putting in a locking function so that once the piece hits the bottom, it's going to stay there. And then also within the code of our program, once a piece is locked in, we're going to tell it, hey, you need to spawn a new piece up top. And then from there, with that, we're also going to be putting in the automatic drop. So the piece will steadily drop and head towards the bottom of our game screen, which with the user control already in place, you can make it fall further if you want to, or fall faster, sorry. So we're just going to stop that right there. So first thing we're going to do, we're going to scroll down a bit. And so under our check collision function, we're going to be adding a new function. And this one we call lock Tetrimino. There we go. Tetrimino, and so from that, with this, we're going to be passing the Tetrimino piece and the grid location. So for row index, row and enumerate. So we're just checking if there's a Tetrimino piece in the row and the specific shape, because always depending on the shape, it will affect when it's actually going to touch the bottom, and the game needs to know when that is. And for column index, val and enumerate. Row, there we go. If our value, if there is a value there, if it exists, our new x equals our Tetrimino dot x plus our column index and the same thing, our Tetrimino y position plus our row index. And so now with these two values, so we're going to be using this every frame, and so it's going to be checking where it's at, and with this, if these values hit a certain point, so in this case, if our y is less than or equal to the 0 position, and then basically if it's at 0 or less than rows, and our x, similar situation there. Then our grid at that location. We want Y and X. So all this is doing is going through each row and going through each row, and at each row it's going to check each column, and it's just checking where our Tetrimino piece is, and it's updating basically it's updating these variables here are new X and new Y, and those are just it's just what we're using to check position. And here with this new Y and new X, if they're if they hit the bottom of our window here, that's what we're checking, the grids in those locations are going to take on the color of the Tetrimino piece that is there. So that's how we're going to allow the game to keep track of what pieces are actually at the bottom. All right. Wait, do we have? Oh, oops. There's a few other things I need to update. My bad. I'm getting ahead of myself today. So to help us with what we're doing, sorry, I'm getting a little ahead of my notes. We have a couple additional functions to create. So we're changing how we're handling our grid going forward. I'm very sorry. I got ahead of myself there a little bit. So we have we're having taking that functionality out of what we were doing, and we're putting it. Oh yeah. Okay. I'm sorry. I should have checked my notes a little bit better before we got going. It's not gonna be a problem though. All right. So we're actually gonna move this just a little bit. This is what happens when you'll leave something sitting for a few days, and then you come back to it and you forgot what you did. All right. Our grid return. 0, 4 in range columns. And range rows. All right. And from here, we're just going to okay, now with this, what's going to be happening is in our main program, we're going to be creating a grid variable that we're doing that will pass into the actual draw function. And so we'll be creating that here in a few minutes. But what this is going to do is it's going to change up just a little bit of how we do some of this. But we're doing this so that we can track what the Tetrimino piece is at the bottom, because what we're really doing is we're just taking that grid and changing them to that Tetrimino piece color and then going from there. And color of our grid is Y and X. If grid Y and X else is, what do we, it'll be our grid color. So what this is doing, this right here. All right. So what this does is we take our grid, which will be created by this new function. We're going to pass, and we will draw it by passing it into this function, the draw grid. And now it's going through and it's going to check what color is assigned it. So if there's a color assigned to it that's anything other than the gray, that will be assigned here. If it's something else, well, that's for this, it will get this grid coordinate. If there's a color there that's been assigned specifically through this lock Tetrimino function, that's the color it'll get. If there's no data there, it's just going to be whatever our grid color is. In this case, it's gray. And then we just take that variable and we pass it here. Hopefully it's not too confusing. All right, now we can actually get back into everything. Sorry, again, it's been a few days since I looked at all this, and you kind of forget a few things, especially with work and all the other stuff that just goes on with life. So with that, we have to create a couple more variables before the game actually starts running. So first thing we have to create is our grid, and with our grid, we just have to create grid. And then we have our fall speed. And we'll set that at 500. And I'm going to leave a little note for ourselves. This is in milliseconds. Or this will be calculated with milliseconds. And then last fall. Pygame dot time dot, I apologize, if you're hearing any barking, I have laundry going, and my dogs are not a big fan of the washer or the dryer, especially the washer. Alrighty, that should be everything we need. Yep, so now we have the new way of creating our grid. We have our fall speed, which is going to be in milliseconds, and we also can use this last fall variable, which is how we're actually going to check for each one, and that's just this inbuilt function in Pygame where it just gets the ticks. Alrighty. And now we can get into sprucing up. Give me just a moment, everyone. I'm going to go make sure my dogs are good. I'm back, everyone. My dogs are good. They were definitely just barking at our washer, but everything's fine. Alright, so now... Oh, I am looking at my wrong screen. There we go. So now we will be updating everything. So first things first, we're gonna update. We're gonna jump down a little bit. We'll be adding a little bit up top here in a minute. But I want to go ahead and update these that we need to. So we have our screen fill background. That's not going to change. Our draw grid, now we're going to pass on this grid variable we had up here. And then that's actually the only thing we have to add right there. So now we're going to add some new stuff up top with what in our actual while loop. So current time equals Pygame dot time dot get ticks. All right, and then again we're using all this the Pygame dot time dot get ticks is to help track where everything's at. If our current time minus our last fall is greater than our fall speed, we're going to have the piece drop. This equals 1. If our check collision current grid. So the current dot y minus equals 1. And then we're going to lock our piece. And what this is doing is just making sure that if the piece is, once it hits the bottom, it technically will go below the bottom of our grid, but this just pushes it back up. It pushes it back up and it'll keep it there. And so that's why we have this, because we have check collision, so we're checking the current Tetrimino piece with the current location of the grid, and we're pushing it back up, so we're making sure it stays at the very bottom row. It will not go beneath that. That's why that's there. And then we're going to lock our current piece. Go. And then we are going to create a new Tetrimino. Wait. Oh. I misspelt it. Oh, I did. That's why. It's fine. That's what happens sometimes. My notes and what I don't, everything doesn't necessarily line up like it should. I'll have multiple different windows open looking at multiple different things, and it just happens. Random choice. Oh, that's why. Again, I am so bad at typing sometimes. Shapes. Random dot choice. Colors. Make sure that's... Yep. And now, last fall equals current time. Alrighty. I believe that's everything we need. I'm gonna run the code and check it. Oh. What did I do? At 84. Alrighty. What did I do here? Why is it angry? I'm going to pause the video here. I'm going to look and figure out what it is, and as soon as I figure it out, I'll let y'all know. Alright everyone, I'm back. I realized what I did. I forgot to update one of our other functions. That is all on me. So from here, I got to scroll back up to our check collision. So it's getting mad because it only accepts that I send a Tetrimino, but I was also passing the grid to it. So one thing we have to do, we have to add the grid, but then we also have to do something with that. So what's going to be happening is we're going to be updating this right here. So thankfully, there's not a whole lot we got to do. We just have to add a couple lines. So this, if our new y is greater than or equal to 0, and our grid new y x, we return true. Oh, I can spell. There we go. Okay. We're just adding additional. So what's going on here is this check collision and why it was getting angry. One, we were passing two things to it, two variables, but it was built the way we had it, only accepted one. So now it takes the grid in, and what we're doing with that is it's running the check. It's making sure that there's nothing, that it stays within the bounds of our game window, of our grid. But now we're checking, it's also going to check as it falls, is there something there? Is there a pre-existing Tetrimino piece? This will make sure that as the Tetris game plays, the pieces will stack on top of each other. That's all that this line is doing, or these two lines are doing. Now, let me press F5 to run it. There we go. And it's angry again. All right. Stop that there. And like earlier, give me a moment and I'll be right back. Okay, I'm back. And again, just stupid little things I forgot to do, because if you come through here, you can see check collision. So we updated the function further up, and so as soon as I tried to control it, it's only getting one piece of information, but it requires two, so that's why it's throwing the error. So all we have to do here is pass the grid to it. And we have to do it for all three lines. And there we go. So hopefully now everything works up to this point. All right. Get my mouse out of the way. Okay. Oh, should be pretty easy fix. There we go. That was just, I misspelt. The game's not always going to see that, or stuff like that. As you're coding, as you're making your own thing, things will only show up when it's running, and especially with Python. So, let's see if it works now. Hopefully that simple fix should have corrected the issue there. No. Oh, there we go. And this piece should sit perfectly on top. There we go. All right. And let's see if we can slide this in. There we go. I just realized there's something wrong. Oh. There's something wrong. But I'm going to fix it next lesson, because the colors should be locked to specific pieces. Or we may not be that far in the lesson, but that'll be what'll happen in the end. But I'm not too worried about it. Otherwise, what we wanted to do is done. The pieces will land on each other. We have the game will run. We can move the pieces will fall by themselves. We can force them down faster, and then it also just randomly cycles through the pieces and their colors, which we actually will be making the colors locked to specific piece types, but not going to worry about that tonight. So we have accomplished everything we wanted to accomplish this lesson. A few hiccups, but that'll happen. And then yeah, so that's just going to happen. Eventually we'll program ends, like once the pieces hit the top, game over. But otherwise, I thank everyone for stopping by. Had a few hiccups this lesson, but I like showing those because nothing's going to run perfectly. Even here I have notes. When I have notes I created for all this, and I still ran into issues just because I got ahead of myself, and that's going to happen a lot. But don't let those little things dissuade you. It's not a big deal. So I hope everyone has a wonderful week. I'll catch you next time, and have a great time programming, and just keep on keeping on.